Hello students, welcome to our channel. Today we will discuss a problem on quadratic equation which had been asked in last JEE Mains 2024. And first you should try the problem, pausing this video, then I will help you to solve this. Okay. The problem is given that fx is a function 2 to the power x minus x square for all x in R, and m and n are the respective number of points at which the curves y is equal to fx and f dash x intersects the x-axis. Then what will be the value of m plus n? We will solve this problem using graph, and we will conduct a thorough analysis so that the similar type of problems students can tackle in future. Okay. Now, to determine the graph of fx, we have to observe his nature. Okay, to do this problem we need first some theories. A function fx is increasing if dash x is greater than 0 and decreasing if dash x is less than 0. Okay, now look, f dash x is 2 to the power x log e2 minus 2x. Now we cannot say this function is increasing or decreasing, so this is not clear to us. So we will derivative it once again. Now what f double dash x is 2 to the power x log e base 2 minus 2. Once again, this is not clear. Either the function is positive or not. Now if triple dash x is 2 to the power x log e base 2 whole cube. And we know that exponential function 2 to the power x is look like this. Okay, at x equal to 0 it will be 1, and at the negative portion it will be asymptotic to 0, and then it goes upward, so it is always positive. Okay, according to this theory f double dash x will be always increasing function. Okay, now we will determine the graph of f double dash x. First we draw the graph of f triple dash x, which is an exponential graph. Now since f double dash x is always positive triple dash x, so f double dash x will be an increasing function. Now look, as if x tends to plus infinity, f double dash x will goes to infinity, and if we take x tends to minus infinity, f double dash x tends to minus 2, because this part will be 0. So the graph of f double dash x will be like this. At x equal to y is equal to minus 2, it will be asymptotic, and since it is increasing it will cut x-axis at exactly 1 point. Okay, so this is the graph of f double dash x, and we suppose that it cuts x-axis at the point x equal to gamma. Okay, now we will draw the graph of f dash x. Okay, now from the graph of f double dash x, as we can see that before gamma f double dash x is negative, and after gamma f double dash x is positive. So f dash x will be increasing just after gamma, and f dash x will be decreasing before gamma. So this graph may look like this. This is the point gamma, may look like this. Okay, we don't have still now enough clue to say that gamma will cut x-axis or not. Now we will see the rest of the things. To fix this problem, we will use Rolle's theorem, which says that between any two roots of fx, there is a root of f dash x. That is, if fx is a function which has two roots, say alpha and beta, then there must exist a root between alpha and beta of f dash x. F dash x has a root between alpha and beta. This is the Rolle's theorem. We will use this theorem. Now, just simply look the function at the function fx. From general observation, we can say that x equal to 2 and x equal to 4 is a solution of fx, because at x equal to 2 this is 0 and also x equal to 4 this is 0. So we can use theorem 2, that is Rolle's theorem, and we can say that there must exist a root of f dash x between 2 and 4. Okay, so this graph of f dash x must cut x-axis. Okay, this graph must cut at x-axis. Now we will draw the graph of f dash x. So f dash x will be like this, and suppose alpha and beta be the. One more thing, that at as x tends to minus infinity, f dash x tends to plus infinity, and x tends to plus infinity, f dash x also tends to plus infinity. So it will cut x-axis twice. Okay, because it have to from upward it will come down, and then will have to come to plus infinity. So f dash x has two roots, alpha and beta, and now f dash alpha is equal to 0. And what is f dash now f double dash alpha? We can derive that f double dash alpha, because alpha is on the left side of gamma, so f alpha will be here and beta will be here, and f dash alpha must be negative. Okay, from this graph we can say that f double dash alpha is negative. So if alpha is the local minima at x equal to alpha, f dash x will have local minima, and the same thing for f dash beta. F dash beta is also 0, and what is f dash double dash beta? It's positive. So at x equal to beta, fx has local maxima. Now we will finally draw the graph of fx. Clearly 2 and 4 is the solution, so it will cut x-axis at 2 and 4. Now as we can see that f of 0 is 1, so at x equal to 0 the function must be positive, and as x tends to infinity, fx tends to infinity, and as x tends to minus infinity, fx tends to minus infinity. So it will be from the left side cut x-axis on negative side once, and then 2, and then 4, and then go upward, and alpha is the point of local maxima. This must be alpha and this must be beta. This is 2 and this is 4, and somewhere on the left side because f of 0 is 1, somewhere on the left side fx cut x-axis. So this is the complete figure of fx, and fx cut x-axis at 3 points, and f dash x cuts x is at 2 points. So m is 3, n is 2, so our desired result is 5.